got their test back from chapter 8? Won't have to have this. Because I wanted to make sure we go over that one. That's what it was. So, is this an integral or are we evaluating a limit? Limit. So, some of you did this. Is that enough for the AP to say, yes, you checked that L'Hopital's applies? Okay, the answer would be no. I've never modeled that and distinctly said, no, you absolutely must pull apart the numerator and test. Some of you didn't know how to do this test because you're like trying to integrate. You can't integrate this. This doesn't work as an integrated thing, by hand anyway. Plugging in 0 though, integrating from a point to exactly that point, I can evaluate the integral at just 0 to 0. Plugging in 0, now L'Hopital's applies. And those of you who got this far, what is the derivative of that numerator? Sine x squared, period. Derivative of the integral is the stuff inside with the limits of integration plugged in. Some of you kept t. Some of you did the chain rule of the t squared and still left it as t. Derivative of the integral, fundamental theorem of calculus, that's solidly totally going to be on your AP exam. The word fundamental would be that word. Derivative of the bottom, 3x squared. One of you clever little chaps at this point said, hey, well that's sine of stuff over stuff. If stuff goes to 0, it's going to go to 1/3. Did the Ellie rule. I was like, oh, clever. I was like, yeah, not what I wanted you to do, but you're right, true. Many of you did this again, which is what I wanted. L'Hopital's applies again, and derivative of sine is cosine, leave the inside alone. Now chain rule. And now I can cancel the x's and plug in the 0 and I get 1/3. Many of you went yet another round and did it right. You did product rule. If you went another round and didn't do product rule, you missed some stuff. But just wanted to make sure we're okay with that idea. Akon?
They keep stuff like having rules.
On the free response, I'm not sure because it is a thing that we do teach as like, you get to use this as a shortcut. I would think they would, but they're fickle sometimes, so I can't just bank on that. Were there other questions on the test that people had issues? This was the big thing I wanted to make sure we covered. It was a point to pull the infinity off. And then, a lot of you knew this was arc 10. Good. A few of you are still holding on to like bad notation. Once you do the integration, the curly Q moves from the left to the right, it becomes a straight bar. It's a notation you need to do. It says, I did the operation of integrating already, and now I need to evaluate. So it matters which way you do things. Some of you said this was infinity. And part of the reason AP exam is obsessed with arctan, one of you even wrote it on your test, two naturally occurring something or others, but didn't really remember what it was. Was that you?
Yeah, I drew a picture too.
You're like, two of them, I don't know. So, two naturally occurring something or other. AP loves it. Because as we go to super duper infinity, arctan flattens out to pi over 2. And whereas tangent 0 at 0. So that answer was just pi over 2. Any other issues with the chapter 8 test? Because chapter 8 is part of chapter 9, really. It is. Convergence rules, they'll come back when we have to test endpoints. All right. Yeah.
Can you remember number 4?
What was number 4?
Limit of x goes to infinity 1 plus 1.
Limit is x goes to infinity 1 plus.
1 over x.
X to the 2x.
Oh. So whatever number I chose to put over that, 2x, 5x, 3x, 4x, it'll be that number, e to that. Yeah.
I think it's 2 over x. I think it's
Two-
just 2x. But it might be different.
Sorry, so
I had the 2x.
2x, okay. Okay, we're evaluating a limit, not an integral. I have a moving target to a moving target, so when we have that problem, we need to do E and ln. And I'm gonna move stuff around. ln of this stuff, and I'm shooting, can I move the 2x down right away?
Yeah.
Do 2 steps at once, thanks. L'Hopital's does not apply, I don't have a fraction, so I need to force a fraction to happen. So that becomes 2 natural log of this stuff. Now I'm evaluating a limit and a fraction. Plugging in infinity, 1 over infinity is about 0. Natural log of 1 is about 0. That goes to 0. That goes to 0, so the derivative of the top over the derivative of the bottom. 2 is just there. Derivative of natural log of stuff is 1 over stuff times the derivative of stuff. Derivative of 1 over x multiplied by the power, lower the power. And in the denominator, multiplied by the power, lower the power. Some of you, in doing the work, you combined those guys inside and you made the problem so much harder. And some of you, like, just the way you wrote your work, you confused yourself. Because right here, I see those guys are exactly the same and they reduce. So it was kind of sad. I watched you guys like tie yourself up in a knot because you clearly understood the math and then you got lost because you simplified things or you combined things and it didn't help. But now plugging in infinity, 1 over infinity is 0, 1 over 1 is 1. then that times 2, so it's e to the 2. So I needed to see that you knew to do e to the ln. I needed to see that you knew to bring the exponent down. I needed to see that you created a fraction. I needed to see that you tested each piece for L'Hopital's. Then that you were able to do the derivative correctly and remember chain rule for this one. And that they reduced and that you were able to evaluate. Cool. So today I would like you guys to do the homework. It's hard homework. Were there issues with this one? Like this was hopefully just plugging stuff into the patterns. And interval of convergence, you can't quite do some of those yet. If it's if it's a geometric, squish that between -1 and 1 and solve. Sorry. This one, if you look on the back of the packet for 9.2, the interval of convergence is infinity, negative infinity to infinity. I'll show you that later. Can't do it yet. I need to teach you ratio test. But anyway, try the homework and I'll come by and answer questions or, yeah. And there's textbooks around the room.
Yeah, I
It'll never be 2 series. Can you not do series?
It's not one that's
We also, when it's non-zero, it just means zero. Yeah. So that's great to make sure. We're like talking about this, but I don't even know. You know what I mean?
Paste together things for
Oh, I used to write it in red.
each and every one of these derivatives is one times. Like we did for
It's geometric, it's always like this like this stuff. Because that's
Right, I think Okay, this is basically so like
Oh.
zero.
Wait, zero.
Oh, yeah. Sounds like they're taking out the class direction. What does that have to do with
Right, well, like in the Taylor series, is like this one. And you know that the second time
Yeah.
So if this is used.
that's the stuff. You know that.
No, but then you keep it where it's even.
Oh, or you
So we have to do like an even.
So you just replace.
So who is signed up?
You got that.
And then divide it by X. And then first term.
So each one of us.
Because you're dividing each one by X. Like,
know, I figured I'd try it out for a 17 first weekend. So that,
yesterday we did, sorry, and
That's like-
distributed X every year. This one we're just dividing it and as long as we still get
so I actually go back and try to understand. Make sure it's gonna
You do X to 2n times
Sorry. Anna, which question?
21B.
21B. Like, the 21, all of them stand, like, that I have 4 or 5 of these problems written up, color coded, so I can be like, the pink line? Like, these are hard. So look at it when you're switching.
Well, zero, and then this is.
sign it.
Where is this?
And
The thing we found in pink is so I'll H prime because I got there is that pink. Again, H, I need to integrate, right?
Yeah, we already know that that's one.
They want to be, the H equals 5, H of 0 is 5. Only a coordinate, so I can find the C value. Oh, wait, so, but I gotta integrate these pieces. So raise the power, divide by the new power, and that's all I did. And then I got a C that I had to plug in, well, X is 0, now plug in a 0, C has 0. Okay, now the question, all right.
Why wouldn't you do like chain like this? Why don't you just why would it for everything?
Yeah, I don't know.
Like derivative of sine,
But that,
and like
I'm told
cosine.
the series for sine of stuff,
There's another.
stuff in front of the
Yeah,
wall.
maybe
So you need to do.
Like, whenever you choose to plug in some polynomial, I tried to like prove myself by doing it and
Oh, yeah.
so, I don't know. But they were allowed to do it, so.
Series of negative because
That one, so that was 1 minus x squared. Okay. That looks really close. Well, if I can, raise the power.
Oh, because that's. Oh, so we have to evaluate sine x over x. Before zero, take the limit. Well, we already know that, that's one.
Oh, you're doing that.
Let's just take a given. So k should be one.
I want this one.
To get you a whole different.
So, when I would have thought of doing it, except the problems with where let's do this one.
Oh, it is.
Hey, let's do this one. It was like,
The derivative is what is the function.
Right.
so I need to do derivatives going to so this works like it's the derivatives to do.
But in part B, that is actually true. It's like, you would take it it's like weird. It's like oh no, that's like
So,
you're trying to find like
I know.
yeah.
I don't get it.
And then do X. You remember
And then put me together again.
So even this two sets of two is a series where sine is but this is all the same thing.
Alright, using this
I did.
idea,
Exact.
But like sometimes it's really.
Alright, guys, I need to show a different irritating colored problem. 19. So 21 was up for a minute. There's 19. Take a look at it and then I'll combine it. So first,
Okay, let's go back to 3.
is asking. So, do the derivative, this is G, do the derivative, evaluate it at 1. And then
First time non-zero terms.
using the series that we came up with,
The colors are confusing.
what is G prime of 1, it came up with, G prime of 1. It says plug in 1, so I plugged in 1 for all those x values. And I got this number 1 over 2 factorial, 2 over 3 factorial, 3 over 4 factorial. That's switched up to be, the nth term is n over n plus 1 factorial. So, just trying to say, prove that the sum of all those guys is going to be 1. And just for fun, this morning I got an email from Matt Brown. It was like, hey, so Bestie, I just proved this thing about the ratio test. I know you're in chapter 9 right now. And he sent me one full page of teeny tiny writing of his homework. It was just one proof. And he's like, hey, show everybody. Yeah, well, he even put a little smiley face at the bottom. It was cute.
For 19B, I did it, but I got the same argument for it. I did kind of pulled out one of it, and I just interpreted it as BS minus 1. And then found it, and I integrated the term, and then divided it.
But to do the derivative x, that denominator is like a thing.
Like, you can't do the thing that we did over here, we just multiply each
When you're doing a derivative, all the variables need to be there. Constants you can pull out, but variables need to be part of it. It's just quotient. What is? It can be.
What makes it not? You say it can.
It's how it's taught.
That Mr. Young. I don't know. I think this is it. Is that the physics teacher?
Dunn is one of we have enough we have teachers. We have multiple teachers in physics. Look. Problem set 5. Do these 3 things. Here's my favorite part. The smiley face at the bottom. And he really means it. He's like, yay! Look at me. I did it. That's Brown.
Yep. So that was right, their general terms. I was always writing it like instead of like in the format of like numbers, I was always writing to the end.
They wanted the actual, they wanted that, like. They wanted things that I don't know if it's possible. And the things that are gonna stay in these series are X's and N's and all of them.
Yeah, then the sorry, I hope you have something like for Geovex you had like
Okay, so on, there's two things. There's G of X, the function, and then there's G of X, the series. They asked in the problem, not very well, but they asked in both of them, find both, and the function generates 0x. So here's the function, here's the series. The derivative of the function just with quotient rule that we knew in September. And then piece by piece do the derivative of the series. So this guy's G prime equals the series is G prime. And then they were like, oh, instead of G prime for any X, make it 1. And look at the pattern that happened when we plugged in 1 for all these X's right here.
Okay, so they want you to kind of sort of separate.
And then pull them together. Oh, okay. So this guy's derivative, that was easy, and why would we ever do this series? I don't know. And I mean, I do know it's that they want to know what does this guy go to? It equals 1. I wouldn't have thought to expand this and know to go backwards, but if they're forcing me through to match them up, I'm like, okay, I got you. Yeah.
How do you find the series? Because you see how it is.
Okay, part A.
Yeah.
Part A, I got the series E, X over 3.
Yeah.
Because they and then in part B, they asked for CDX minus 1 over
Yeah.
What is that?
E to the X minus 1
No, not for me.
You literally just have to.
The probability. No, that's X.
this whole series, I'm multiplying by the 1 over X out here,
Oh, I was talking about the big next.
and the numerator also had that minus 1, so
Yes, I know what you're talking about.
this is all the stuff in parentheses minus 1. The reason they needed to do that was those guys had to cancel. And now, can X be reduced to which terms remain? And then for part C, it's like, oh, do the derivative of that stream stuff. It's just, it takes a minute or more.
Okay. Oh, that's probably.
Yeah.
They didn't write, so I did the derivative and then we wrote. And then they were like, hey, look at this new pattern that I found.
I just get way too.
Oh, this? Oh, it's that.
This, it's like the thing where she is like cosine of X and cosine of 2X, you can plug in the 2X to every single problem with X. And so this, I just plugged in two, like, X over 2 to every single spot where there's X. And so
So
like,
I just plugged in one to that.
I did
One
X
times
over
e to the one that was minus
2
one,
yen,
one plus one.
and then so like my series is like x over 2, x over 2 is 2, x over 2 is 3, and then times the factorial piece each time is just.
They're- Okay.
Oh, yeah.
Sometimes we get these infinite series patterns
Oh,
that
yeah, you're right.
you're like, what is that gonna equal? And why?
What?
That's something I don't
What
know.
makes sense?
Nice TV actually makes sense.
I don't know.
TV, bro.
I don't know. I'm not there.
I had it as
I'm still thinking like
If I understood that.
like you start with because you start with one.
Don't ask me just about what task. Why is that what it is?
You didn't do the subtraction. You didn't do the subtraction.
It's just like,
What?
Right, like see how
Do I have to know?
see how our first term is 4.
No.
Like my first term is 1 also.
That is probability.
One side
That
0.
is,
minus one.
So I
Plus.
Oh my god.
Oh.
so you don't even need to
so,
write it.
if it's 5.
They don't
Yeah,
even
it's like everything inside.
And then when you simplify it, it turns into what she has.
Like you fucking
So now that's where
like negative, like negative
Say
one
I
over
can
x.
wait to write it, different way of writing it.
Negative one over x.
Like, but is it the whole? Like,
That's
zero
okay.
spot?
You just-
Can you explain it to us? I don't know what you're Oh, that's.
Yeah, so yeah, I have that.
1 x over 2 and x over 2 squared.
Gets rid of that shit. It is really actually.
How do you, like, I don't understand.
I mean, how do you do quotient? How do you do quotient?
I ripped it last night. I didn't see it. It's like, a lot of times the derivatives. I tried to research derivatives. That was like February. I was so bad.
It's like, it's like.
I was really upset. But honestly, like, I was
Take this big deal out of it. Seriously? If I zero. Oh, wait, no.
I actually did something.
You don't know the actual value.
Yeah, I remember the story. No, I told her what I what's the story? My father would show up and call me and talk about math.
Do you still?
Yes. No.
Oh.
What? 3 times.
And
Outside of
Is it on your?
Oh, essentially.
My grade's still up. What's your grade? God damn. This is a derivative. This is a derivative. This is a series. Derivative of the Chinese series to find the series. Right, and then I think series. This is the derivative. To find the series. And then you make a general term of all of those terms, you get this. So you prime at one. It's like what we're trying to do is prove that that equals one. That's what we did.
Use an MRI.
N equals one. Keep on adding that to it, you'll like have one.
Oh, yeah.
It's okay.